A Lewis diagram is a visual representation of how the bonds work between the two nonmetals or any atom you have here. So right now I have a few examples on specific compounds, and I'm going to show you how we make the Lewis diagram for each of them. So the first step is to count how many valence electrons you have in each compound. So let's start with H2O. So hydrogen, they each have one electron, one valence electron, so it's 1. And then there's 2 of them, so you add another 1. And oxygen has 6. So in total you'll have 8. And now we place the elements, and for this case many people know the diagram for water, but O's in the middle, and then you have H on the sides, right? And normally you'd put the least electronegative element in the middle. And yeah, so next, assign the bonds. That's step 2, so to make sure they're actually bonded. And now let's count how many electrons we used. When you have a bond, that represents 2 electrons per. So now we lost 4 electrons, so now you have 8 minus 4 equals 4. And now next step after we assign the bonds is we fill up the shells. The hydrogen can only hold 2 electrons in each cell, so the hydrogen octets are full. Oxygen is not, it needs 4 more electrons, so if we just place the 4 electrons here, and we're done. Next, CO2. Check how much electrons it has. Carbon has 4, oxygen has 6, and there's 2 oxygens, so there'll be another 6. And this will be 16 electrons. Next, we place the least electronegative, so that would be C, and put the O's in between. Next, we assign the bonds. So you have one bond here, one bond here. It's kind of whatever. And now we count how many electrons we used. So there's 2 bonds, so that means we lost 2 per. So now we're at 12 electrons. And now we assign it to our outermost electrons first. So in this case it'd be oxygen. Each oxygen needs 8 valence electrons in its outermost shell. This has 2, so we're going to just assign 8 more. And now we use 6, so now we're at 6. We have 6 more electrons. We put it on this side, and now we can see that we use all our electrons, but carbon's octet is not full. So we remove 2 electrons from oxygen and we assign it as a bond. And we do for the other side. And now if we count, we have 2, 4, 6, 8, 10, 12, 14, 16. So we have enough. Now, next step would be to check kind of the formal charge. Now, for the formal charge, there's a formula which is it's only per element. So it'd be the amount of valence electrons in your element and this number you'll subtract it from the non-paired electrons. You'll subtract it from the amount of bonds you have. And most things they'll tell you bonded electrons divided by 2. I mean, you don't have to do that. I kind of just, what the hell's happening? I kind of just put it as number of bonds. So let's check the one for C. Carbon has 4 valence electrons. It has 0 unpaired electrons, and it has 4 bonds. So 4 is 0. So you always want the formal charge to be as low as possible, or if most preferably 0. For oxygen, it has 6 valence minus, there's 4 unpaired, and there is 2 bonds, 0, and it goes same for both sides. Now things get more complicated when it comes to ions. So first, what we're going to do is we're going to first, assess what ion this is. This is nitrate. It is NO3 and it has a charge of -1. So first, let's count how many electrons there are. Nitrogen has 5 valence, and oxygen has 6. Each has 6. And remember, it is an anion, meaning that it has gained a specific amount of electrons. In this case, only 1 electron. So this in total has 24. So now just keep going through the steps. Let's bond N and put it in the middle because it's the least electronegative. Put the oxygens around. Assign the bonds. Now, whenever you have an anion, you always put a little bracket. And you put the charges. Now, the thing about the anion is when you calculate your formal charge, you always want the formal charge of every single element to equal your charge, your actual charge. So what do I mean by this? Well, let's just keep going and we'll find it out from there. So now we just bond everything. So now we have how many left? We have 18 left. So now we just bond. Why is it doing that? Bond. So we just bond all of them together. And now we check nitrogen doesn't have its octet filled. So we take off 1 and we put a bond like this. So now everything's stable. And now let's check the formal charge of each. Let's start with nitrogen. So nitrogen, it has 5 valence electrons. It has 0 unpaired, and it has 4 paired. So 4 bonds. So this would equal +1. That's not a bad thing. Let's look at every other element. Oxygen has 6. This oxygen right here, and these two, they have 6 electrons -6 because 6 non-paired, and they each have 1 bond. So this will equal -1. Since there's 2 of them, this will be times 2, which will equal -2. Let's look at this oxygen right here. This has 6, 4 unpaired, and 2 bonds equals 0. Now, I think you guys can see where I'm going with this. We add the formal charges, -1 minus 2 equals -1. And this equals your total charge, so you know that this is the correct configuration. Now, one thing that you may have noticed is I just chose that oxygen out of nowhere. Why didn't I choose the one on the right? Why didn't I choose the one on the left? Well, you can. This isn't the only configuration of it. I don't have to put the bond over here. I can put the bond, instead of it being here, I can put the bond over here. And same thing for the other side, I can put the bond over here, right? And we call that resonance. That's when it's interchangeable. You can put the bonds in whatever, because it's not restrictive. Now, how do you write that? Well, let's take off these, and instead of putting like a dash, instead what we're gonna do, sorry, my bad, what we're gonna do is instead of writing like a solid line, we're gonna write a dashed line. So we have each bonds here, and this will be a dash line here, dash line here, dash line here. That's what resonance is. But again, they can also show you just the difference, the different ones. So it can show you one Lewis structure where it's bonded for the first oxygen, and then the second one, the second oxygen, third one for third oxygen. That's the whole resonance. Next, this is a question that I believe Doctor gave us to make the Lewis structure of, and so we're gonna do it here. So now, first we calculate valence electrons. S has 6 valence electrons. Oxygen has 6 valence electrons, has 4 of them, and remember it is -2, so you have 2 more electrons from there, and this equals 32. So now we put the least electronegative in the middle, which is S. Then you have O, 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 O around. We sign the bonds. I should have kept the structure there. Just give me 1 second. So now we check how much electrons are left. We used up 8, so 32 minus 8 is 24. And don't forget, we need the little brackets here to minus. So we have 24 electrons, and we're just going to bond them. And as you see, every element is bonded. And now we can check the formal charges. S has 6 valence electrons, 0 unpaired, -4. This is equals 2 plus. And every oxygen here has 6 valence electrons, has 6 unpaired, and -1. This equals -1. Since there's 4 of them, this equals -4. Now this looks right because if you add those two, they equal to minus. But another thing about formal charges, you always want to minimize as many formal charges for elements as possible. So in this case, right, we can try to minimize other elements. And for this compound, sulfur can have what we call an expanded octet. So we can put more than 8 electrons in there. So let's check what can we do exactly. Well, we want to try to reduce S's formal charge as much as possible. Remember, S's formal charge was +2, right? So we want the +2. We want to go lower, right? So this kind of just you just do a bunch of experimenting for this, but what you really do is you remove 2 of these and you put them as double bonds for the sulfur. So now you have 6 valence electrons, 0 this, and you have 6 bonds, makes it 0. And we check the other elements. These two oxygens here, they have 6 minus 4 unpaired minus 2 bonds equals 0. There's 2 of them equals 0. And these stay the same, so you have -2. So you get your same answer. Now, resonance is also here. Like, it doesn't have to be, put a different color actually. It doesn't have to be these two. It can be these two, or it can be these two. Like, I think you see what I mean. Like, there is resonance present here. However, here it's kind of a little bit more difficult to write this because there are two bonds that can happen instead of just one. But that's just a summary on how to write your Lewis structures. And obviously, you should practice more, and I'll probably put some more practice for the next video. And so that's basically all there is to the Lewis diagram.